Now we are in example 10 where a rectangle is to be inscribed in a semicircle of radius 2. What is the largest area that the rectangle can have? We are provided with this diagram here where we have a semicircle inscribed with a rectangle. The length of the rectangle, say from negative x to x. And the equation of the semicircle given as x squared plus y squared equals to 4. So, for the value of x here, the y coordinate can be obtained by having x squared plus y squared equals to 4, and we can write y squared as 4 minus x squared. Therefore, y will be set of 4 minus x squared. Therefore, the coordinate obtained is x set 4 minus x squared. Now, we are in step 1 to identify the variable to be maximized or minimized. As we seen in the question, we need to find the largest area of the rectangle. For that, we will start to have the formula for finding area of the rectangle. So, area of the rectangle is the length, which is 2x, times the height, follow this coordinate, which is set of 4 minus x squared. So, this combination will give us 2x multiplied with 4 minus x squared to the power of half. Well, we are now in step 3 to solve f prime of x equals to 0. We have skipped step number 2 since our a is written as a single variable function. So now a can be written as 2 times 4 minus x squared to the power of half. Finding derivative of this dA over dx can be obtained by using product rule between the first and second expression. For that, we keep 2x and start to differentiate the second term, which is half times 4 minus x squared to the power of negative half multiplied with differentiation of the term inside the bracket, which is negative 2x. And we need to add with maintaining 4 minus x squared to the power of half times with 2 derivative of the term 2x. Next, we will have dA over dx to be equivalent to 0, in which 2x multiplied with, cancelling this 2 and 2 will give us negative x over set of 4 minus x squared plus 4 minus x squared times by 2 equivalents to 0. And here we can have negative 2x squared over third 4 minus x squared as equals to negative 2 third 4 minus x squared. We can cancel out this negative 2 and negative 2. Therefore, we will have x squared over third of 4 minus x squared equals to third of 4 minus x squared. Now, to simplify further this equation, we need to square both sides of the equations. Squaring both sides will give us x squared over third 4 minus x squared equivalents to set of 4 minus x square is being squared. So as the result, we will have x to the power of 4 over 4 minus x square, as well as on the right hand side 4 minus x square. Computing this further, x power of 4 is equivalent to 16 minus 8x square plus x to the power of 4. So this will give us 8x square minus 16 equals to 0, and we will have x square minus 2 equals to 0, and x will be set 2 and negative of set 2 as critical numbers. Well, now we are in step 4 to verify the first derivative critical numbers using second derivative test. For that, please refer back to our first derivative function, which is quite long here. In this case, it is not easy, or it's quite tedious to find the second derivative of this function. For that, instead of using second derivative test, we will test the critical numbers using the first derivative test. So remember, our critical numbers were x equals to negative set 2 and set 2. Placing them on a number line in increasing order, we will have negative set 2 followed by set 2. So the first portion here can be written x less than negative of set 2. And for the middle part, x values will be greater than set of 2 but less than set 2. And for the third part, x greater than set 2. Next is to choose the test value. Say for x less than negative set 2, we choose test value to be negative 1.5, and here we choose 0, and here we use 1.5. Substituting the test values in the first derivative function, for negative 1.5 we will have a negative sign, and for substitution of 0 we will have a positive f prime of x, and for 1.5 again we will have a negative sign. So whenever we see a negative sign, it shows the graph is decreasing. Positive sign, the graph is increasing. Negative sign, the graph is decreasing. Well, we are now in step 5, where to obtain the optimum value y according to the question. Based on the first derivative test that has been carried out, we are able to see that at critical value set 2, there is a changes in the graph from increasing pattern to decreasing pattern. So this is the way or the place where the maximum area happens. For that, the area which is maximum can be calculated using formula 2x times 4 minus x square, in which we will substitute x value to be set 2. So, set of 4 minus set 2 square here will give us 4 unit square. Therefore, the maximum area of the rectangle is 4 unit square for this question.